Cameras are a vital tool for preservation of history and memories, communication, and artistic expression. While the invention of the camera dates back to the early 1800s, it wasn't until the 1970s that the technology used for the modern digital camera was invented. Digital camera, how it works. A digital camera has a similar basic structure to a film camera. The body, which is represented here as a rectangle, has an opening in the front for a lens. The lens has several layers of glass that light passes through. Inside the camera, there is a reflex mirror, and rather than having film at the back, as there would be in a film camera, a digital camera has a sensor that captures the light that streams through the lens. The sensor reads the light and ultimately sends it through to an analog to digital converter that processes it and sends it to be stored in a memory card. Now let's take a closer look at the function of each of the camera's components. The reflex mirror is important in its role in allowing the photographer to see the image they wish to capture. It is angled in from the lens so that the light that hits it is sent upwards into the pentaprism. In the pentaprism, the light hits different mirrors and is sent outwards so you are able to see the image by looking through the viewfinder. When you take a photo, the shutter opens and the reflex mirror flips upward to let the light directly hit the sensor in the back of the camera. The sensor is the most important part of a digital camera. Its basic function is to capture light and convert it into electrical signals. In other words, it changes the light's photons into electrons. There are two types of sensors found in digital cameras, known as complementary metal oxide semiconductor and charge-coupled device sensors. They both work relatively the same, but a CMOS is a cutting-edge version that is cheaper to make and works faster. To understand the basic function of these sensors, we'll look at a CCD sensor. The technology behind the CCD sensor has been around for 45 years. The sensor's base is made out of a slab of silicon that is divided into a grid with aluminum strips and channel stops. Each section or photosite on the surface is a pixel. Each pixel registers the amount of light that falls on them and converts it into a corresponding number of electrons. More or less electrons are generated based on the strength of the light. These electrons are then transferred one row at a time and sent to the analog to digital converter that reads their charges, turning the data into a string of ones and zeros, therefore constructing the image to be sent to the memory chip in the camera. Interestingly enough, CCD and CMOS sensors are colorblind, so in order to document the color, there is a filter over top called a Bayer filter. The Bayer filter is a mosaic of red, green, and blue sensors that through an algorithm determine the exact color of each pixel. One pixel comes from a grid of 9 colors, 5 green, 2 red, and 2 blue. Each square of color is called a stencil, and red, green, or blue light is only let through the corresponding colored stencil to be read by the CCD sensor. The exact pixel colors are made based on the levels of light recorded from each color in the pixel. This same process is used to determine over 1 million pixels to construct an image like this beautiful one here. Thanks for watching!